In this video, we are going to be talking about factor pairs and multiples. First, we are going to be using a rainbow number line like you see here to find factor pairs of a number. So looking at the number 16, I want to think of all the different possibilities of factors that I can multiply to get to 16. So I'm going to start with the number 1, and I'm going to think 1 times what will give me a product of 16. So 1 times 16 will give me 16. It's very important not to forget the number itself times 1 when you are listing factor pairs. Okay? And I'm just going to go down the line. I know that 2 times 8 will also give me 16. I did not write 3 because I do not have another number multiplied to 3 that will give me 16. So then we skip to 4 times 4 is 16. And that is the end of our factors for 16. Now when you're asked to write them as a factor pair, you're going to write them as a group of numbers, as a group of 2 numbers with a comma. So 1 and 16 is a factor pair, 2 and 8 is another factor pair, 4 and 4 is another factor pair. If you have doubles that are a factor pair, it's still important for you to write both of the 4s. Let's look at another one. Now let's look at the number 24. We're going to write the factor pairs for 24. So I know that 1 times 24 equals 24. Let's think about 2. 2 times 12 equals 24. 3 times 8 equals 24. 4 times 6 equals 24. And I'm going to think about our other possibilities just to make sure I didn't miss any. 5 does not work. 5 times another number does not equal 24. 6. 6 times 4 equals 24. This is just the commutative property of addition. We cannot use 7. We can use 8 again. I'm going to have to kind of squish that one in there. And we cannot use 9 or 10. And then finally, again, we do have the commutative property of 12 and 2. That one is its own separate rainbow there. I did not leave enough room. So you can see as you start and get closer to the center section of that rainbow, you can tell that you are going to be finishing your factor pairs. Now, to write them, our factor pairs are 1 and 24, 2 and 12, 3 and 8, 4 and 6. And I can stop there. I do not need to repeat the commutative property and write again 6 and 4. Just writing it one way is sufficient for finding the factor pairs. Okay, this time let's try the number 15. So again, I'm always going to start with 1. 1 times the number itself. So each number is guaranteed to have at least one factor pair because we know the number times 1 will always give us that same number. I cannot multiply 2 by anything to get 15, but I do know that 3 times 5 is 15. 4 does not work. We can show 5 again. 5 times 3 equals 15. 6 does not work. 7, 8, 9, 10, 11, and 12 do not work. So we have factor pairs of 1 and 15 and 3 and 5. On your own, draw a factor rainbow for the number 20. And when I would like you to pause the video here, draw your own factor rainbow, finding all of the factor pairs for 20, and then when you're ready, you can come back here and check your work. Okay, so you have created factor pairs for the number 20, and we're going to check them now. We have 1 and 20, 2 and 10, nothing with 3. We have 4 and 5. I could repeat that to show 5 and 4. 6 does not work. 7, 8, 9. I can do 10 again, the commutative property of multiplication. 10 times 2. 11, no. And 12, no. So your factor pairs would be 1 and 20, 2 and 10, and 4 and 5. And then we already have the 5 and 4 covered here, and the 10 and 2 covered here. Now we are going to take a look at multiples. So here it's almost, we can think of it as the opposite of factor pairs. With multiples, I want to think about what numbers. Now I'm thinking of the products instead of the factors. So if I have the number 2, I'm going to list out all of the different multiples. So here I am going to think 2 times 1 is 2. Again, the number itself is always a multiple of itself. 2 times 2 is 4. 2 times 3 is 6. 2 times 4 is 8. 2 times 5 is 10. 2 times 6 is 12. 2 times 7 is 14. 2 times 8 is 16. 2 times 9 is 18. 2 times 10 is 20. 2 times 11 is 22. And 2 times 12 is 24. And I could keep going on and on and on. But for our sake, these numbers are multiples of 2. Let's look at another one. Let's find the multiples of 6. And I'm just going to list out, this is just like listing out a multiplication fact table. 6 times 1 is 6. 6 times 2 is 12. 6 times 3 is 18. 6 times 4 is 24. 6 times 5 is 30. 6 times 6 is 36. 6 times 7 is 42. 6 times 8 is 48. 6 times 9 is 54. 6 times 10 is 60. And I'm going to stop there. We could continue. So all of these numbers from 6 to 60 are multiples of 6. I'm going to have you try this one on your own. List out the multiples for 7. I'm going to have you pause the video here, write the multiples, any of the multiples that you can think of for the number 7. When you've completed that, come back to this video and then we can check your work. Okay, multiples of 7. 7 times 1 is 7. 7 times 2 is 14. 7 times 3 is 21. 7 times 4 is 28. 7 times 5 is 35. 7 times 6 is 42. 7 times 8, whoops, I missed 7 times 7 is 49. 7 times 8 is 56. 7 times 9 is 63. And 7 times 10 is 70. You may have continued on to 11, 12, 13. That is fine. But these are the multiples of 7, from 7 to 70. So we've reviewed factors. Remember, factor pairs are sets of numbers that, when multiplied together, give us a product. So for one final example, the factor pairs for 35 would be 1 and 35, and 7 and 5. And also talked about multiples. Remember, multiples, we're multiplying a given number by the other numbers to find the different multiples. So multiples for 5 are 5, 10, 15, 20, 25, and we could continue that pattern.